everybody, welcome back. I'm hoping that there's no backup audio to this today. I think I fixed it. Sorry about yesterday. And just to review real quick, because I know it was quite distracting and you couldn't really focus, I just wanted to review at least the one part of sig figs that you had a hard time hearing, which was counting sig figs in a number. And so there are rules to counting sig figs. And the first rule is anything that is not a zero always counts as significant. So in this number, 7 is not a zero, and 8 is not a zero. So they always count as significant. So the other three rules deal with zeros and their location. You need to classify the zero as being in one of three places, either before the non-zero digit, which never count, between non-zero digits, like this one, which always count, and after non-zero digits, like this one, which count only if there's a decimal point in the number. So this zero is between the check marks. If the zero is between the check marks, the zero always counts as significant. So that captive zero will count. This zero is after the non-zero digit, and it will only count if there's a decimal point in the number. There's no decimal point in the number, so this is a placeholder. This only has 3 sig figs, okay? That's how we do it. So the 5 is not a zero, it counts. All 3 of these zeros are trailing zeros. They're after the non-zero digit. There is a decimal point in the number, so they all count. There are 4 sig figs, okay? The 1 counts, the 4 counts, the captive zeros always count, and the trailing zero counts because there's a decimal point in the number. So this has 5 sig figs. It's very important for you to know how to do that before we go on to counting with significant digits and computing. So there are really 4 mathematical operations you could perform: addition, subtraction, multiplication, and division. And there's different rules depending on what your mathematical operation you're performing. Adding and subtracting is the same rule. Good thing, there's only 2 rules. The rule when you add or subtract, which I call the AD rule, okay, is your answer must have the same number of places after the decimal. That's why I call it AD. Plus, when you're adding or subtracting, you follow this rule. AD for after the decimal. So your answer must have the same number of places after the decimal as the number in the problem with the least. Okay? So let's apply that rule to a problem. And all we're going to do is round. So if I am adding these numbers, I just add them in my calculator, 12.11, or in your head, plus 18.0 plus, 1.013. And the number I get is 31.123. So you add them and write out the whole big long answer and then round it, following that rule we just wrote. My answer has to have the same places after the decimal as the number in the problem that has the least places after the decimal. So this has 2 after the decimal, this has 1 after the decimal, and this has 3 after the decimal. So I need to round this number so that it only has 1 place after the decimal. I look to the right, it's not a 5 or higher, so I would round this to 31.1. Okay? The idea is that my answer can't be more precise than my least precise measurement. And my least precise measurement only goes to the 10th place. So my answer can only go to the 10th place. Okay? That's the idea. When you multiply or divide, it's a different rule. It's not AD, it's TSF. And what TSF stands for is total sig figs. But it's the same concept, that your answer must have the same total sig figs as the number in the problem with the least. It's always the least, right? You can't be more precise than your least precise measurement. So we call this TSF. So again, in example, we will multiply. When you multiply, you care about total sig figs. So we're going to take 4.6 times 1.4 and get a whole big long answer of 6.384. I really do want you to write down the whole big long answer so that I know if you made a calculator mistake or a rounding mistake. Now, that is not your answer to proper sig figs. We must apply the TSF rule. So I count total sig figs. These are all not 0. So this has 3 sig figs. And this is not 0. This has 2 sig figs. So how many sig figs do you think I need in my answer? If you said 2, you're right. We have to have the same sig figs as the number in the problem with the least. So I start counting. This is significant. This is significant. And I stop there. Now, this is an 8 or higher, which is going to make that 3 round up to a 4. So you don't have to ask me what place should I round to if you're following sig fig rules. And that is why on certain problems like you saw on the gases test, when the number was 226, they actually rounded it up to 230 because they were only allowed to have 2 sig figs. Okay? There are 5 problems here in your notes that deal with different mathematical operations and calculating. What I want you to do is 2 things. I want you to write the rule here. So for example, since we're adding, I care about after the decimal. I want you to perform the calculation and express your answer to proper sig figs. Write the rule here. I'm multiplying, so I care about total sig figs. Perform the operation, write your whole big long answer, and then express it in proper sig figs. So I would like you to do for tomorrow when you come in, numbers 1 through 5. If you do not have them even attempted to be done, you will not get credit for watching the video. So please make sure you take a look at those after you turn off your computer. Have a great night, everybody. We'll see you tomorrow where we will do more practice with everything sig figs. Have a great night. Bye-bye.